man, would that be more convenient? All right, so here we are. So again, solve for each variable. So we're rearranging these equations, right? So what do you want to get first, x or y? X, why not? So is the 3y or the negative 5 bothering the x? No, so leave them alone. There's two things bothering the x. Number one is the plus 1. Number two is the 2 that's being multiplied by the with the x. Remember, you can do whatever you want. PEMDAS is a lie. How do we get rid of the 2 in front of the x? We would divide, right? Because we want to separate the 2 from the x, like divorce, right? Now remember, just like divorce, if you divide, every single term has to get divided by 2. I'd rather save that for the end, right? Divorce should be the last option. Same thing with division. So let's move the 1 over first. So we get 2x equals 3y minus 6. Now, why is that a minus 6 now? Yes, Jace.
Because whenever you minus the 1 on each side, it's just adding a negative 1 to the negative.
Exactly. So I subtracted 1 from both sides. So I have a negative 6 here now instead of a negative 5. And the 1 has been moved over successfully. Now, what's the only thing left bothering the x? Yeah. The 2. And the 2 is with the x, so we need to separate them. How do we separate with math? Divide, like divorce, right? So we divide everything. Now, when we do this, there's a couple ways you can do it. You can either go x equals 3y minus 6 all over 2, right? Because that's dividing everything. Or you could have also written x equals 3 halves y minus 3. So notice, what I did is I applied that division. What's 3 divided by 2? 3 halves. What's negative 6 divided by 2? Negative 3. Either way works, okay? It's important that all the terms get divided, though, right? Everything in divorce gets split. Yes. So here we are. Either answer works. Now let's go get y. So I'm going to write down the whole problem again so we can see it. This side is fine, right? We don't mess with that. We need to get rid of the minus 5 and the divide by 3. Again, division, last resort. Let's get rid of the minus 5. How do we get rid of the minus 5? We move it by, everybody. Addition. Addition. We add it over. So now we have 2x plus 6 over here equals 3y. Now to get y on its own, we need to separate the 3 from the y, and we separate by division. So now everything gets divided by 3. So we have two possible answers here. We have all over 3, which is the answer I prefer, right? Because it's a lot easier to do. We also have this answer. 2/3 x plus 2 equals y. Either way works, right? Because 2 divided by 3 is 2/3. 6 divided by 3 is 2. How you feeling? Dece? Yes. Okay. Awesome. Number 2. X, y over 9 equals 2p. You want to get p on its own first? Let's do that. All right, so what's bothering the p? 2. So we're going to divide to separate it from the p, right? So check it out. We have xy over 9 equals 2p. When we divide by 2, we're dividing a fraction by a fraction. Think what this means. It says xy divided by 9, now divide it by 2. So that's the same thing as saying divide by 18, right? If you divide something in half, here, let's do this. Easier illustration, okay, for your young, fragile minds, okay? So last night, I stayed here super late, listened to some AC/DC and did some math problems, because that's just what I do with my life, okay? If you were here, you probably heard it. It was super, super loud. I also listened to Fire Orchestra, which is like that crazy weird noise you're hearing all the time. Yeah, good band, new album, came out in May, and no one told me about it. So check it out. You have a pizza, right? If you divide it in half, you've divided by 2, right? Yeah. Now what happens when I divide in 2 again? Well, dividing in 2 twice is the same thing as dividing by 4. You see what I'm saying? So if I divide something by 9, and now I divide it by 2, it's the same thing as dividing by 18. Do you see how that works? So xy over 18 is what I get. And the reason for this, if you're like, oh man, I just don't see it, check it out. Dividing by 9, let's have x over 9, and now we're going to divide it by 2. Well, another way instead of dividing by 2 is multiplying by the reciprocal. What's the reciprocal of 2? Half. 1/2. So let's multiply by a half instead of dividing by 2. Remember, half of something is the same thing as saying divide by 2. Of is the multiplication word. Half of this. Well, what happens? We multiply across. We never do cross multiplication, ever. All it does is confuse you, okay? Across. What's x times 1? X. What's 9 times 2? 18. Told you, right? So we have xy over 18 equals p. That is p. Okay? Now let's go get x and y. So xy over 9 equals 2p. Is the 2p bothering the x? No. What's bothering the x? The divides by 9 and the times y. When we want to make a better world, the first thing we do is we look for the division, right? Is there division? Yes. Then we get rid of it. How do we get rid of division? Multiplication. Bow, chicka, wow, wow. Great American melting pot, right? So we bring people together, and everything multiplies. Gross. All right, so everything's going to get multiplied by 9 to get rid of that division. So over here we get xy, right? Because that gets rid of the divides, right? Gets rid of the division. And over here we're going to multiply by 9. Well, 2 is going to multiply by 9 and make 18. And notice this is one term, right? So we did multiply p by 9. Okay, that's one term. That whole term got multiplied by 9. So we have 18p. Now let's get x on its own. You'll notice that from here we can get x or y pretty easily. So if we get x on its own, what do? We need to separate it from the y, right? So we're going to divide by y. So we get x equals 18p all divided by y. Oh, sorry. Tell me to scoot it up, okay?
No, you have it. Right?
Yeah, I know, but it won't be if it's up high because I'm sitting down. So x is 18p over y. Now, from the same point right here, we don't have to go back to the beginning, right? Let's get y on its own. How do I get rid of the x, or separate the x from the y?
Divide by x.
Divide by x. So we're going to get y equals 18p over x. Feeling okay? Dees? You just got back from the bathroom. How was your potty break? Eventful? Bank shot, buckets. Number 3. All right, so we're going to get x, p, and y on their own. What do you want to get on its own first?
X.
All right, so we're going to get x on its own. So that means we got to move the p and move the negative y and get rid of the negative in front of the x, right?
Yeah.
So first things first, let's get the y and the p moved over. So how do I move the y over? Nope, we're not separating it from anything. Addition, right? It's minus a y. Like minus 4, if that was a minus 4, you know what to do. Add 4, right? But it's a minus y. So you add y. So 4/9 is over here, and we add y to it. Now we need to get rid of the p, just like you were doing a little bit ago. How do we get rid of the plus p?
Subtraction.
Subtract it. So we have negative x equals 4/9 plus y, and then we subtracted p, right? Now, how do we get rid of the negative in front of the x? We need to separate it, right? What do? We divide by negative 1. So x equals 4/9 plus y minus p all over negative 1. Or you can apply that to everything. Now, what happens when you divide by a negative 1? Well, dividing by 1 keeps it the same. So dividing by negative 1 just must flip the sign, right? So we have negative 4/9 minus y plus p.
Of course.
Okay? Think about it. Ignore this stuff over here. What if I told you negative x equals 2? So the negative version of x is 2. That must mean the positive version of x is negative 2, right? So here's the negative version of x. Here's the positive version of x, right? It's just with all the signs changed. That's it. We change the sign on this side. We change all the signs on this side. So that's x. Let's find y. So from here, the beginning, is the 4/9 bothering the y? No. It just stays there, which is good because we don't want to mess with fractions if we don't have to, right? Skylar and Parker, see you guys later. Best of luck, gentlemen. All right, so now we're gonna get y on its own. So what's bothering the y? The minus x and the plus p. Let's move over the x first. How do we move over negative x? We add it over, right? If that was a negative 2, you'd add it. Just because we put a letter there, you guys lose your mind, right? You add the x. So now we have 4/9 plus x. Again, we're trying to get y on its own, so we need to get rid of that p. How do we get rid of the p? We subtract it because it's a term that's positive right now. So now we have negative y equals 4/9 plus x minus p. Ladies and gentlemen, how do we get rid of the negative in front of the y? We need to divide, right?
Yeah.
Now what is that going to do when we divide everything by negative 1?
It's going to flip all the sides.
Yep, so we now have negative 4/9. You can either put the negative with the 4 or out in front of it. Doesn't matter, just don't put it both, right? Minus an x and plus a p. Last but not least, let's get p on its own. So negative x plus p minus y equals 4/9. Let's move the x over first. How do we do it? Add it. So we get p minus y, that's a minus, equals 4/9 plus x. That's a minus. Now again, we're trying to get p on its own. So how do we move that minus y over? Addition. Plus x plus y. Boom, boom, boom. P is on its own. Picking up what I'm putting down?
Yes.
Cool.
Yes.
Number 4. Here we go. We're going to get p on its own first, okay? Is the 5 bothering any of this stuff?
Nope.
No. What is bothering the p?
X, Y.
The division of x minus y, okay? X minus y is one idea, okay? So we're going to move it all over at once in parentheses. So kind of like this, right? So what we're going to do is instead, if that was p divided by 2, wouldn't you multiply by 2 to both sides?
Yeah.
Right? So instead of multiplying by 2, we're going to multiply by x minus y. So when we do that, we multiply the whole thing over in parentheses. So it's 5 times x minus y equals p. You see how once we were dividing by x minus y, now we're multiplying by x minus y? Okay? We moved it. So p is on its own. Now, how do we get x and y on its own? This is where things get a little weird, okay? So let's get y on its own first. So 5 equals p over x minus y. Yikes. Okay. So what is bothering the y? Well, the x's and the p is. So here's what we're going to do. Remember the reciprocal? What does it mean to reciprocate? To return, to flip, right? When two things match, right, and you flip them, when they multiply, they make 1. So what we're going to do is we're going to reciprocate both sides. Again, as long as you do both sides, it's fine, right? That's algebra. So what's the reciprocal of 5? What's the reciprocal of p over x minus y?
X minus y.
Oh. We know how to solve this problem, I think. How do we get rid of division of p? So I multiply. Now, check it out. When I multiply, I have p times a fifth. We can do it like that, or we can put p on top, right? Because p times 1 divided by 5 is just p over 5. I'm going to do it like that. That equals x minus y. Now, how do we get y on its own?
Why would you go y first?
I don't know. We could have done x first, but I chose y. Yeah. How do I do it, Jace?
Minus x on both sides.
Subtract x. So we get a fifth p minus x equals negative y. And then last but not least, I'm going to do my last step. How do I get rid of the negative in front of the y? Yeah, divide by negative 1, which flips all the signs, right? So I get negative a fifth p positive x equals positive y. Bam, bam, bam. Yes, sir.
So on the test, you want us to write it like that, not over negative 1?
You could do negative p over 5. That's fine. Oh, wait. Over negative 1? Probably. I mean, I won't work it wrong, but that's just a more convoluted way of writing the same thing, right? It's like when I ask you, what's 10 plus 10? And you're like, oh, it's 1 plus 1 plus 1 plus 1 plus 1, right? I mean, you're right, but write 20, you dingus. Yeah.
Can't you just use that same setup to find x?
Mm-hmm. So from this point, right, we can find x. What will we do to find x from here?
Add the y.
Add the y. So 1/5 p plus y equals x. Good observation, Baker. Saves us some time, right? I did that in the wrong color, but fair enough. I know, it should have been pink, right? It's because we did p first.
Yeah.
How you feeling?
Shake.
Extremely intelligent.
Headache? Sorry, hate when that happens. Shake and bake. All right, number 5. So, you want to get p on its own first? Divide by 2. What's this going to turn into then? 3x plus y over what?
Over 5.
Over 10.
Over 5.
Right? If we cut something in half and then cut it into fifths, we've cut it into tenths, right?
Really?
Yeah, check it out. So here's a pizza.
Oh, yeah, he wasn't here.
If I divide it in half, that's dividing by 2, right?
Yes.
Now I'm going to divide it into fifths. So I do 1, 2, 3,
That's good.
4,
I wasn't hearing this.
5, right? And I have 1, 2, 3, 4. Oh, I just totally screwed this whole thing up. But yeah, when we divide it into fifths and then we divide it in half, right? Every fifth gets cut in half. What's half of a fifth? A tenth, right? You see what I'm saying? You missed the demonstration earlier. It was much better. All right, so now we're here. That's p on its own. Let's get x on its own next because y. Actually, we'll do y. We'll do y. So 3x plus y over 5 equals 2p. So what's the first thing we do when we want to make a better world? We look for the division and we get rid of it. So we're going to multiply by 5 to both sides. We get 3x plus y equals, instead of 2p, it's going to be 10p, right? If I've got 2 pecans and you multiply it by 5, now I've got 10 pecans. Now we're going to get y on its own. So what do we have to do? Do we divide that 3? No, move the whole dumb thing over, right? Move the 3x over. Both have to go. So move the whole thing by subtraction or addition? Subtraction. Remember, we move, it's either addition or subtraction. So we have 10p minus 3x, or negative 3x plus p, 10p. It's up to you. Y is on its own. Now it's time for x. So from here, can't we solve, right, for x? So let's do that. What do we have to do first? You could divide by 3 to everything, right? But then we got a third of y and, like, who cares, right? How about we move over to the y first, right? How are we going to do that, Baker? Subtract the y. So we get 3x equals 10p minus the y we just moved over. Now we divide by 3, yeah? Everything gets divided by 3. So option 1 is we have 10/3 of p minus 1/3 of y, right? Because that's a negative 1 in front of there. Or, probably the way you did it, was 10p minus y, everything divided by 3. Either way works. Okie dokie. It's good to know both these ways because sometimes it is more helpful to do it like that. Sometimes it is. Right now, definitely not. Number 6. How much more we got here? Not much more at all. One more page. All right, so this one. Let's get p on its own first. That looks the easiest to me. So we add 4, so we have 3/4 xy plus 6 now equals 6p. And now how do we separate the 6 from the p? Divide by 6 to everything. Now, because there's a fraction here, I don't want to just put everything over 6. So here's what we're going to do. We're going to divide each term by 6. So this guy's going to get divided by 6. Right now he's already being divided by 4, right? So if I divide it by 4 and then divide it by 6, it's the same as dividing by 24. So 3 over 24, xy. Now we can simplify. What's 3 over 25 by the reciprocal instead?
Yeah.
So let's times by 4/3 to get rid of the 3/4. Let's do that first, okay? So if I times by 4/3, think about what this means. We got 6p minus 6. We're timesing by 4/3. Let me just write it like this so you can see what I'm doing here, okay? Ignore the division bar. That means we are dividing everything by 3 and multiplying everything by 4. Which one do you want to do first? Divide by 3 or multiply by 4? Okay, so we get xy equals everything times 4, which is 24p minus 24 all over 3. Now, fun fact, can we divide these guys by 3?
Yeah.
Yeah, so that's going to be xy equals 8p minus 8. Now, you could have figured this out a lot easier. If you had divided everything by 3 first, right? 6p minus 6 divided by 3, that's going to be 2p minus 2 times by 4, 8p minus 8. Okay? Division sometimes is the better thing to do first. Okay? Can save you a lot of work. Makes the numbers smaller, and we like small numbers. So now we need to get y on its own. What do we do?
Add
Not add.
I'll take that.
Separate the x from the y. How do we do it? Divide. Everything gets divided so we can have it all over x, or you could write it like this, 8p over x minus 8 over x. I don't recommend that one. Either way works. Now, solving for x last. Is there an easy point we can start from to solve for x? Yep, right here, right? So what do we do to get x on its own? Divide by y. So x is going to equal 8p minus 8 all over y. Thank you for telling me. All right, so I mentioned earlier we had an option. We could have done something all at once, and Isaiah was right, sort of, about what he said. So starting here, everybody look here. Instead of dividing by 3/4, multiplying by the reciprocal, same thing, right? And then dividing by x, we can do it all at once. So check it out. Instead of dividing by a fraction, I want to multiply by the reciprocal. I'm going to move this whole thing over, the 3/4 x. Another way to think about that is 3x over 4, right? Because we times by 3 and then divide by 4. What's 3 times x? 3x. Now divide by 4. 3x over 4, right? See how the x goes on top? Okay. If I want to multiply by the reciprocal, I'm not going to multiply by this. I'm going to multiply both sides by 4 over 3x. Now watch what happens. This side right here is 6p minus 6, and I am multiplying by 4 over 3x. The 4 multiplies with the top. So we get 24p minus 24 over 3x. We divide by 3 because those are divisible, and we get 8p minus 8 over x. Another way to think of this, okay? It says divide by 3, divide by x, multiply by 4, right? Let's divide by 3. What happens when you divide everything by 3? 2p minus 2 equals 4 divided by x. Remember, we didn't divide by x yet. Now we're going to divide by x and multiply by 4. That's 8p minus 8 over x. Ta-da! Same. You do what you want. Okay? If you're feeling brave, work with reciprocals. If you're feeling brave, work with reciprocals. There's something to be said for that. Okay, so 7. Here we are. Let's get p on its own, right? Looks like the easiest one. What do I do to get p on its own? Subtract the 2 first. You could have divided everything by -1, changed all the signs. That's not a bad option, right? That's not hard to do. We'll do that later. 5/3 y, we're subtracting 2. We have a negative p here, which means we flip all the signs, right? Division, or dividing by a negative. -1 changes all the signs. So negative 2x squared minus, change the sign, Mr. Mac, 5/3 y, positive 2 equals p. So that's p. Now y, getting y on its own. 2x squared plus 5/3 y equals negative p plus 2. Is the negative p plus 2 bothering y? Mm-mm. This term is, right? We try to get down to one term first before we start doing division and stuff, right? So let's move that term over. How do we move terms? Either addition or subtraction. In this case, it's going to be subtraction. So we have 5/3 y equals negative p plus 2 minus the 2x squared. Did we have to get rid of that square? No, that wasn't bothering the y. Just leave it, right? No roots necessary. Now, how do I get the y separated from 5/3? We divide, but we don't like dividing fractions. Instead, we multiply by the reciprocal. What's the reciprocal of 5/3? 3/5. So y is going to equal all of this stuff times 3 and then divided by 5, right? That's what it means to multiply by 3/5. We times by the top, divide by the bottom. So we're dividing everything by 5. And we're multiplying the top by 3. Negative 3p plus 6 minus 6x squared. None of that's divisible by 5, so let's just leave it. That's y. Now for x. I'm going to do it on a separate sheet of paper. Okay, you ready for this? 5, 4, 3. Here we are. All right, so let's get x on its own. First of all, we should probably get down to 1 on this side, right? So let's move that term over. How do we move terms? Subtraction or addition. In this case, it's subtraction. So we have 2x squared equaling negative p that's already there, positive 2 that's already there, minus 5/3 y. Now we got to get rid of the 2 and the square. Again, we save squares for, and roots for last if we can, because it's kind of like division. It's really messy, right? Like divorce. So we need to separate that 2 from the x squared. How do we separate it? We divide negative p plus 2. Oh, we have a fraction. So we should probably write this differently, shouldn't we? We should divide everything by negative 2. Or, sorry, we should divide everything by 2. So that's negative p over 2 plus, what's 2 divided by 2?
1.
And now we divide this by 2. What's negative 5 divided by 3 and then divided by 2?
A number.
If you divide something in thirds and then divide those thirds in half, 6 equal x squared. Let me zoom this up a little bit. All right. Now we got to get rid of the square. And again, because it's the last thing, it's not that hard. What do we do to get rid of a square? We root it, right? And we root everything, just like division, divorce, right? We root everything. So every term is going to get rooted. So x squared is going to equal all of this stuff rooted. Kind of like a big division bar that encapsulates everything. We're going to have a big root that encapsulates everything.
Wouldn't it be 8 equals everything written?
8 equals?
If x equals. Like,
Yeah, sorry. I did the square again. My bad. We got rid of the square by rooting. Yep. Thanks for catching that, Jace. So, that's that on that.
We have to finish it.
Now, Last page. Simplify. So here we go. This should be easy if you did the last stuff, okay? What does it mean to multiply by a fraction? It means times by the top and divide by the bottom. Now, which would you rather do? Take 24 and divide it by 4 and then multiply by 3? Or take 24 and times it by 3, making it big, and then divide by 4?
Divide by 4.
You'd rather divide by 4 first. What is 24 divided by 4? 6. Now times by 3.
18.
18. Bam, done. You look like a genius, right? Is 3/4 of 24 18? Yeah. That's 3/4 of the way to 24. Number 9. 2/3 of 12. Well, 1/3 of 12 is 4, right? So 2/3 of 12 is going to be 8. But let's think. We could do 12 times 2, which is 24, and then divide by 3. Or we could do 12 divided by 3, and then times 2. 8, right?
Nice.
Do you see how powerful this can be? Like, you were grabbing calculators last year for this stuff, which is embarrassing.
Cool.
Why don't they teach you this? I don't know.
Like make stuff different.
Well, it's this way.
We speak no evil. Number 10.
Yeah, it's like no evil, Mitchell.
Do you want to times 28 by 3 and then divide by 14?
Divide by 14.
Let's divide by 14 first. What's 28 divided by 14? 2. Now times it by 3.
6.
Oh, you can't do this, right? That's 6.
Whatever you do, don't give me a thumbs up if I ask for a thumbs up. Like, just don't. Refuse to. Just stare me down, and I'll just be like, okay, I'm sorry. Okay. Number 11. Woo! All right, so it's 12/5 times 15/3. So what does this mean? This number right here is going to be divided by 3
Yeah.
and times by 15.
No.
Okay? So, again, it's any order we want. So 12 divided by 5. You want to do that first? No. Let's do 12 divided by 3 first. 4. Okay? So we get 4. What's 4 divided by 5?
4/5.
4/5. So we have 4/5 times 15 left over, right? We already did the divide by 3.
It's like
What's 15 divided by 5?
3.
So we have 4 times 3. That's 12.
Oh.
Lots of ways to do that one. You could have done 12 divided by 3 and 15 divided by 5 and got 4 and 3 and gone for it. That's kind of what we did. You could have also done 5 and 3 together, right? If we divide something by 3 and then divide it by 5, it's the same as dividing by 15. What's 15 divided by 15? 1. 1 times 12 is 12. Okay? You got options. Bam, bam, bam. That's what it's all about when you're drawing up plays. You gotta have options.
What are you going to do for the last?
Whoa.
Play games.
We can try and solve.
Play some card games.
Nah. Rest of the time is yours. Use it as you will. Quiz is tomorrow. You should knock this out of the park, right? Come
It's
on.
only one worksheet.
Come on.
Can we get some homework?
Nah.
Yeah. You can box.
Yep. If I look the other way, maybe. But I'm just like, turn around. What? Give you like a good 10 seconds, right? Buckets.
Yeah, make it rain, get some gloves.
Make it rain. I think you're mixing up your metaphors here.
I want to join.